Hello everyone. We now come to experiment number 7b, which displays characters through a serial port, or we transmit characters through the serial port, and we see these characters on the serial window. In this program, we shall be displaying characters on the display, which is called a serial window. We shall enter the ASCII equivalent of the characters, which will be continuously transmitted through the serial port and displayed on the serial window. We've chosen the characters KVGCE with a space to separate two consecutive sets of characters to be displayed. The output looks like this. We need to know the components of serial communication before writing the program. What we need to understand is the meaning of baud, the special register SCON or serial control special register, and the SBUF, or what possibly is the serial buffer register. Let's first see what the meaning of baud is. In telecommunication and electronics, baud is a common measure of symbol rate, which is one of the components that determine the speed of communication over a data channel. It is the unit for symbol rate or modulation rate in symbols per second or pulses per second. In the example here, there are 4 symbols or signal levels. Each signal consists of 2 bits. The baud in this case will be half the bit rate, or the bit rate will be twice the baud. Let's see another example in the next slide. The tri-bit example shows that each symbol has 3 bits. Here, the bit rate is 3 times the baud. Similarly, in the quad-bit example, the bit rate is 4 times the baud. Baud rate is the data transmission rate that determines the symbols per second for serial communication. The microcontroller is connected with COM port of the PC for the purpose of serial communication. So, in order to allow data transfer between PC and microcontroller without any error, we must make sure that the baud rate of the microcontroller matches the baud rate of the PC's COM port. To meet the standard baud rates, generally, the crystal with 11.0592 MHz is used. As we know, 8051 divides the crystal frequency by 12 to get the machine cycle frequency of 921.6 kHz. Internal UART block of 8051 divides this machine cycle frequency by 32, which gives the frequency of 28800 Hz or 28.8 kHz, which is used by UART. To achieve baud rate of 9600, again 28,800 Hz frequency should be divided by 3. This is achieved by using timer 1 in mode 2, which is the auto reload mode, by putting 253 or FD in hexadecimal in TH1 register, which is an 8-bit register. So 28.8 kHz will be divided by 3, as timer will overflow after every 3 cycles. We can achieve different baud rates by putting division factor in TH1 register. Coming to the SCON register, the serial control or SCON special function register. The serial control or SCON special function register is used to control the 8051 microcontroller's serial port. Using SCON, you can control the operation modes of the serial port, baud rate of the serial port, and send or receive data using serial port. SCON register also consists of bits that are automatically set when a byte of data is transmitted or received. Next, we come to the SBUF register. It is an 8-bit register used solely for serial communication in 8051. For a byte of data to be transferred via the TXD line or the transmit data line, it must be placed in SBUF register. Similarly, SBUF register holds the input data received serially by transmit data line of 8051. The moment the byte is written in SBUF, it is framed with start and stop bits and transferred serially through transmit data line. Similarly, when bits are received serially via RxD, it is deframed by eliminating stop and start bits, and a byte of data is received and placed in SBUF. This is the assembly language program to send the set of characters KVGCE and a blank space through the serial port and view it on the serial window. Going through the program step by step, we first initialize the tmod register and set it to timer mode, choosing timer 1 in mode 2. The bit details of the tmod register are as shown here to set it to timer 1 mode 2. Mode 2 is an 8-bit auto reload timer, in this case where TH1 holds a value which is to be reloaded into TL1 each time TL1 overflows. Let's go on to the next slide. SCON is set to mode 1 and receive enable. In mode 1, it is a 9-bit UART and the baud rate is variable. When REN or receive enable is 1, it allows the 8051 to receive and transfer data. In the SCON register, SM1 is set to 1, which is mode 1, and REN is receive enable, which is set to 1. The bit pattern reads 01010000, which is 50 in hexadecimal. Going on to the next slide. TH in timer 1 register is set to a baud rate of 9600 by loading the value of decimal -3 or hexadecimal FDH. We've already gone through this slide where it was explained how we can change the baud rate by loading the TH register of the timer by corresponding divider values. Going to the next slide, we then start timer 1 by setting TR1. The timer starts counting from FDH down to 0. In this step, we initialize register R0 with the number of characters we plan to display. In our case, it is 6, including the blank space after KVGCE. The data pointer will be initialized with the address where we shall be entering the characters that we want to display. Starting from 8000H to 8005H, we enter the ASCII equivalents of K, V, G, C, E and a blank space, which are 4B, 56, 47, 43, 45 and 20H respectively. Get the ASCII of the first character to the accumulator from memory. Call a subroutine to make the transfer through the serial port. The control is transferred to location transfer. The character in accumulator is now loaded to SBUF register. SBUF register holds the data before it is transmitted to the TXD. Transmit interrupt flag, or the TI bit, is an important flag bit in SCON register. When 8051 finishes transfer of 8-bit character, it raises the TI flag to indicate that it is ready to transfer another byte. It is used at the beginning of stop bit. It is set to 1 at the beginning of the stop bit for mode 1. It must be cleared by the program. The bit 1 in SCON register is the TI flag, which will become 1 when the timer finishes counting. The TI flag must be cleared by the program before the next character can be transmitted. The program execution returns to the next instruction after a call transfer. Increment the address in memory location to get the next character to be transmitted. Decrement R0, which is used to keep count of the 6 characters to be transmitted. If R0 is not 0, then go to next char and repeat the same procedure. When all the 6 characters have been transmitted through the serial port, start the program from the beginning. This is an infinite loop where the set of characters will be transmitted repeatedly till we stop running the program. Let's go over to Keil to see how to run the program. We have the program here displaying characters on serial port. Save the program, translate, build, and debug. Now we have to first enter the ASCII characters of KBGCE and a space, which are 4B, 5, 6, 4, 7, 4, 3, 4, 5 and 2, 0. So we'll first go to the memory, view, memory window. There we'll select 8000 because in the program we've selected 8000H. So there you enter them serially. 4B, 5, 6, 4, 7, 4, 3, 4, 5 and 2, 0, which is a blank space. After that, go back to view, and here you have serial windows UART1. So your KBGCE blank space will appear in this area when you run the program. Run the program and this is what you will be able to see: KBGCE blank, KBGCE blank. So because we've written it in a continuous loop, this will be displayed infinitely until you stop running the program. When you stop it, you can see the window here. Okay, that is how it is executed. I hope you understood this. This is a very small program. It involves timers, serial port, SBUF, SCON, all those registers. So that you will have to anyway study it in the theory. So study these topics nicely, and I'll come back with another program. So this will end with the only the software programs. Then we go on to the hardware programs. I'll simulate the hardware programs on Proteus, and I'll upload that very soon. So till then, study well, stay home, and stay safe. Take care. Bye bye.